Have you ever stared at a murky river or maybe some industrial runoff and just wondered, how polluted is this actually? I mean, sure, we can see the floating trash and we can definitely smell when something's off, but the most dangerous pollution in our water is literally invisible. So how do we actually know if a batch of wastewater is clean enough to safely release back into the environment? We need precise scientific metrics to measure what we can't see.
Welcome to this explainer. Today, we're cutting through the alphabet soup of wastewater management. We're going to break down two massive acronyms that pretty much govern water treatment worldwide, BOD and COD, and we'll look exactly at how these metrics are applied within Indian water quality standards. Here's our roadmap for today. We'll start with the invisible water problem. Then, we'll answer the questions, what is BOD and what is COD? After that, we'll put them head-to-head in a showdown, explore something called the treatability ratio, and wrap it all up with Indian water quality standards.
All right, Section 1, the invisible water problem.
Let's get right into it. When organic matter, stuff like food waste, sewage, or industrial byproducts, when that hits a water body, it doesn't just float there harmlessly. It basically acts as a massive, all-you-can-eat buffet for naturally occurring microbes. And as these bacteria feast and multiply, they breathe. They gobble up the dissolved oxygen that's already in the water. If there's way too much waste, they consume that oxygen much faster than nature can replenish it. The result? The water goes completely anoxic. It literally suffocates the fish and destroys the whole aquatic ecosystem. So a low oxygen demand means clean water, while a high demand is a huge red flag for heavy pollution. But how do we actually measure that demand?
That brings us to Section 2. What is BOD? BOD stands for biochemical oxygen demand. Simply put, this metric measures the exact amount of dissolved oxygen that live microorganisms consume while they're biologically breaking down organic matter. Think of it strictly as a measurement of what bacteria can eat. The standard test measures this over a period of exactly 5 days at a highly controlled 20 degrees Celsius. Keep in mind, it doesn't capture everything in the water, only the stuff that's biologically degradable.
To give you a real-world look at this, check out this standard 300 milliliter glass bottle. It's got a ground glass stopper with a special water seal on it. Why? Because you absolutely cannot have outside oxygen snaking in and ruining the test. Plus, while they're incubating, these bottles are kept in total pitch-black darkness. That's to stop any algae in the water from performing photosynthesis, which would generate new oxygen and completely throw off the readings.
This perfectly explains the actual testing methodology governed by the Indian standard IS 3025 Part 44. It's a pretty straightforward three-step process. First, you measure the initial dissolved oxygen in your sample. Second, you seal it up in that glass bottle and lock it in a dark incubator at 20 degrees Celsius for 5 days. Finally, on day 5, you pull it out and measure the final dissolved oxygen. The difference between those two numbers? That's your BOD. But as you might have guessed, waiting 5 whole days for a result is a massive operational headache if you're trying to manage a fast-paced water treatment plant.
Moving right along to Section 3, what is COD?
Because a 5-day wait is usually just too long, engineers rely heavily on COD, or chemical oxygen demand. The big differentiator here is that COD doesn't care about live bacteria. Instead, it measures the amount of oxygen required to chemically oxidize all the oxidizable matter in a sample, organic and inorganic. So if BOD is what bacteria can eat, COD is basically what fire can burn. It captures all the biodegradable stuff plus complex synthetic chemicals, dyes, and anything else those microbes just can't stomach. And since we aren't waiting around for bacteria to finish their incredibly slow meal, the COD test is fast. By using super strong chemical oxidants, usually potassium dichromate mixed with boiling sulfuric acid, in what's known as the closed reflux method, we can totally obliterate all the organic matter in the sample. This aggressive reaction takes just 2 to 3 hours. When you contrast that agonizing 5-day wait for BOD with a 2-hour turnaround for COD, you can see why COD is the absolute workhorse for real-time monitoring in treatment plants.
Section 4, the BOD versus COD showdown.
Let's put these two side by side to really highlight the differences. BOD represents a biological reality. It zeroes in on biodegradable pollution, relies on those finicky live microbes, and takes 5 days. COD represents a chemical reality. It's a brute force measurement of everything oxidizable, relies on harsh chemicals, and gives you actionable data in under 3 hours. And here's the crucial takeaway. Because COD measures everything BOD measures, plus all the non-biodegradable stuff, your COD value is almost always going to be higher than your BOD value. Here's how this plays out in the real world.
As you can see, there's a really strong positive correlation between COD and BOD in typical wastewater. When COD goes up, BOD generally trails right up there with it. Because of this highly predictable relationship, operators can run a quick 2-hour COD test and use it to instantly estimate what their 5-day BOD result will likely be. This is a total game changer. It means they can tweak their machinery in real time instead of waiting a whole business week just to realize something went wrong. Section 5. The treatability ratio. Now, this is where it gets really cool for water engineers. If you simply divide your BOD by your COD, you unlock what's basically a diagnostic cheat code. If that ratio is 0.5 or higher, which happens a lot with food or dairy wastewater, it means the pollution is highly biodegradable. You can just throw it in standard biological tanks and let nature do its thing. But if the ratio drops below 0.3, common in textile dyeing or pharma waste, it means the pollution is highly synthetic and toxic to bacteria. Biology isn't going to save you there. You'll need harsh chemical interventions to break it down. Finally, Section 6, Indian Water Quality Standards. Zooming out to the big picture, the Central Pollution Control Board, or CPCB, sets strict legal limits based entirely on where the treated water is going. If a factory dumps its wastewater into a concrete public sewer, the rules are somewhat relaxed, BOD up to 350 and COD up to 600. But if they're discharging into an inland surface water body, like a natural river, those limits plunge to a maximum BOD of 30 and COD of 250. And if that water is being reused for gardening or cooling, even stricter. Basically, the closer the water gets to a natural ecosystem, the tighter the leash becomes. But hey, it is incredibly important to point out that everything we just discussed is for wastewater. When it comes to the municipal water that actually flows out of your tap at home, it's a completely different ballgame. That water falls under a super strict set of standards known as BIS 1172. Unlike wastewater, the acceptable limit for BOD and COD in our drinking water is practically zero. Any detectable oxygen demand means active bacterial contamination, making it totally unfit to drink. Things like pre-chlorination, aeration, and advanced filtration make absolutely sure our drinking water is fundamentally pure. We've seen today how absolutely vital BOD and COD are for protecting our ecosystems and enforcing environmental laws. But it does leave us with a pretty fascinating dilemma. As modern manufacturing creates more complex synthetic chemicals and forever plastics that bacteria simply can't digest, the gap between what biological tests can see and what is actually in the water is widening. So I'll leave you with this to ponder. In a future dominated by advanced, non-biodegradable synthetic chemicals, will traditional 5-day BOD testing eventually become obsolete? Thanks for joining me on this explainer, and keep questioning the science around you.